right? So please see, we'll see just a little introduction about how we use. Again, we have ML data. That ML data is being converted to system of linear equations. That system of linear equations we are converting to matrices. So we are solving system of linear equations by solving matrices. By solving that matrix data, you are trying to find out solution for that, right? So we'll try to see how matrices are used or matrices are created in Python. So you can see we have to use this package Numpy. Numpy stands for numerical Python. Numpy stands for numerical Python. It's a library provided by Python programming, and it's very powerful library. We have two very important libraries, Numpy and Pandas. Okay, so Pandas is built on top of Numpy. Numpy has lot of functions. Pandas is especially only for matrices. Okay, so Numpy is Pandas is built on top of Numpy. So both are dependent. Pandas is dependent on Numpy. Okay, so you have to use this. This is very common command. Import Numpy as NP. We use shortcut. Why we need to write this as NP? Because to instead of avoiding writing Numpy always everywhere, we are using a shortcut, a alias name for it, NP. So I am running it. You can run this. This is a Jupyter notebook. So then I am creating a array. How do you create a single dimension array? You can give one variable name, arr equal to np dot array. In round brackets, you have to give it like this, 10, 12. So this will create you. If you run, you can see if I change it here, the values, maybe if I can give 15 and 12 and run, we get the matrix as 15 and 12. Okay, so this is one dimension, how you create matrix. See, our goal is to load a big matrix into Python environment and try to solve it. I have to give matrix as an input to my Python library, that linear algebra library. I have to give that matrix. It will automatically solve within milliseconds. It will solve and give me what is the solution. It is not worried about how it is converting into, whether it is using Gaussian elimination or row echelon form, reduced row echelon form. That is all backend. We are only seeing the solution. So I have, this is how you create. You have to use np dot array. NP stands for Numpy, that alias name which I have created, dot array. So array, using this function array, you can create an array. You can give n number of elements here. So this is one dimension array, 10, 12, 30, 40. If you give, it gives you one dimension array. So you can also create like this with multiple elements, np dot array 1, 2, 3. See, it is giving me, and print, you use print function to print the values. Whatever print is, you know about print. Anybody who knows programming knows about printf or print statement. So I have created one more array with 123, 1, 2, 3. I got it. And you can also these are again different ways of creating arrays for easy creation of arrays. Okay, if I give np dot a range of 3, np dot a range of 3 means array with range 3. A range 3 means it will give values from 0, 1, 2. So it will give me an array. If you see 0, if I give here a range of 5, it will give me values from 0, 1, 2, 3, 4. Range function is one important function in Python, where if you give range of 5, it prints the values from 0 to 4. Okay, so same way you can also give, yes, in that range function you have multiple things. In that range you have multiple things. How? Here you can give a start value. So this one indicates start. From where should I start? If you see here in the previous function, when I give np dot a range 5, when I give this, it is starting by default from 0 to 4, right? But if I want to start it from 1, this way you have to give. You have to give the start value, you have to give the end value, and you have to give a increment. Like by default increment is 1. If you don't give, if you see, if I remove this 3 from here and if I run, see, it is giving 1 to 19. It is starting from 1. Always the end integer -1 it will be printing. It will print only till n minus 1. If you are giving a range of 5, it is printing from 0 to 4 only, not till 5. Okay, same way when you give from 1 to 20, it will give only till 19. Now you see, by default the increment value is 1. It is incrementing by 1 always. See, 1, then 2, then 3. If I change this to 2, when I put if I specifically give the increment value to 2, it will increase 2 times, like 2 elements, 1, then 3, then 5, then 7, that way, leaving 1 element. So incrementing by 2. See, 1, 3, 5, 7, then so increasing 2 numbers always. If I give it 3 here, it will increase 3 numbers. Why are we learning this arrange function? Sometimes you want to create a matrix of having more zeros and ones. Then it is very easy for you to create it. Okay, so this is one, and there are a lot more functions. We will try to see them, which is they are not much important for us. Now see this one. I want to create an array with all zeros in it or all ones in it. See, just write arr equal to np dot ones. Ones is a function which is available in Numpy library. Ones is a function in Numpy library. If you can run this, it gives you value 111. You ask me, sir, why there is a dot here? Dot because by default all the elements of array will be float. In Python, if you are using Numpy library, by default all the elements will be float. So if you want to change it to integer, you have to give like this: d type equal to d type equal to int. If you give like this, now let us try and see. So it is giving all ones here. So now everything is integer. So you have to give data type, d type equal to int. If you give, it will give you all values as integer. So np dot ones to create a row or a single dimension array with all ones. np dot zeros, ZEROS, to create all elements with zeros. So again, I have to include this. If I include this, so you get all zeros here. Okay, same way you can create an empty and zeros are same. Here it is also filling with zeros, no difference. So if I write d type equal to int, you get all zeros here. Okay, sometimes you want to have randomly you want to print an array. So there is one function rand, rand, np dot random dot rand. So rand is a function available in random package. Random is available in this np library, numpy library. If you use this, when you give rand function, it will print any values randomly between 0 to 1. See, any values between 0 to 1. This is all about 1D. We are not worried about 1D. We want about 2D, because matrices is a 2D array. So 2-dimensional array equal to np dot array. See, I have given 2 list as input. So it is giving me 2. This is a matrix now for us. Okay, so 2 rows, 2 cross 3 matrix. So you have to give 2 list like this: 1, 2, 3 as one first row, 4, 5, 6 as second row. Okay, and here if you see, without giving any dimension, here I am clearly mentioning the brackets. If you see the square brackets given here, I am clearly giving it. I am having outer bracket, then I am having 2 inner brackets. First row contains 123, second row contains 4, 5, 6. Right? So I am clearly specifying that 2 rows and each row with 3 values. But sometimes if I give values like this, 1, 2, 3, 4, 5, 6. Okay, suppose you have an array like this. You want to convert that array, a single dimension array, into a 2-dimension array. You can use this function reshape. Reshape is one function available in Numpy, which will transform according to your need. See, here I am telling, convert this array 1, 2, 6 single dimension array into a 2 by 3 matrix. So it is giving me answer as 1, 2, 3, 4, 5, 6. But what if I make it 3, 2? Let's see this. If I make it 3 and 2, if I run this, see, you got 3 rows and 2 columns, right? So you can, this is just little introduction, but I'll directly show you. Our target is to see loading a matrix into Python environment, finding out the solution, solving system of linear equations. So this way you can load a matrix now. I hope you understood. You can create np.array. You can give numbers. You can give either in this format, or you can give using reshape function. Give the elements. It will load the matrix. There are some more functions. ndim. Ndim means dimension of the array. Is it a single dimension array, or a 2-dimension array, or a 3-dimension array? N dimension. So if you use the array name dot, its n dimension. it will return you what is the dimension of that array which you are creating. Same way shape, it will give the size. Shape if you give, it will tell you what is the size of the matrix. Is it 3 cross 3 or 4 cross 4, that way. And there is one more here, one more function, size. Size will tell you total number of elements in the that array. That whatever array you have created, what are the total number of elements in that? That is given by this size. Okay, so remaining all addition, subtraction, this is all possible, and multiplying with a vector. Okay, you are just having an array with that with you. You want to multiply with one number, so it will multiply and show you, right? So this and all keeps going. I will just skip all these things. This is more about playing with Python programming. We will see how to load a matrix and how to solve it using uh, linear algebra function, right? So let us go here. Yes, this is the part which we are looking for. How do we solve a system of linear equations? So there is one function, linalg, linear algebra. Okay, in Numpy there is a separate module, that is linalg. You can read about it. It is available. I will share these documents with you. So linear algebra, we have directly one method or module called linear algebra, a function in the Numpy library. Okay, so same thing. See, our target is to load a matrix, solve it, right? So import Numpy as np. As usual, I have to do this. Then I am creating a matrix of size 3 cross 3. I hope you can see here. I want to change this to integer. Let's take integer values. So I am creating a matrix A, which is of size 3 cross 3, and I'm creating a matrix with B minus 10, 0 and 17. B matrix, because we have AX equal to B, right? Matrix AX equal to B format. So I'm trying to load, take input of two matrices A and B. So if I run this, I have got matrix A and I have got the array B with me. Now I will see simple command. This is just to play with that shape, but you see here, just simply write x equal to np dot lin algebra, linear algebra function, linalg dot solve those two matrices. You give A is a matrix, B is a vector. You give as input and you just print the value of x. If you run this, see, you can see the answer. Okay, you can see answer 4, 1, 4 minus 2. It means for a given matrix, of 3 cross 3 and a B matrix minus 10, 0, 17, if you use this function, the command is like this: np dot lin alg dot solve, and give two matrices as input, A and small b. If you give that, it will quickly, within seconds, it will solve and give it to you the solution. See, we got the x1, x2, x3 values. I hope you understood this. That's it. It's that easy. So yesterday's session, whatever we have seen, we seen how we are calculating finding out the solutions, solving system of linear equations by using Gaussian elimination method, by converting it into row echelon and reduced row echelon form, right? But here that knowledge is not required. In machine learning, when you are loading, when you want to form a regression equation, you have to load your data set. But there is one thing we will highlight here. See, what is my matrix actually? What is the data of the matrix? Data of the matrix is the data set, ML data set. And as I told you, we can apply that for small data sets. You can do regression analysis. You can apply those techniques for small data sets, right? So when you have an ML data with you, data set with you, that you are trying to convert into system of linear equations, then to matrix form, and then you are trying to solve it and form a regression equation. So that's why I have loaded a matrix here. Right? I have a matrix. This is this. But you can ask me, sir, I want to, if I have more higher dimension, maybe 20 cross 20 data I have with me. Okay, if I have 20 cross 20 data with me, I want to solve that. I want to solve the system of linear equations. Then we have to go for pandas library, where we convert that data set into a data frame. Data frame is kind of a matrix for now, you assume. If you are not aware of it, it's kind of a matrix. So higher dimension matrix. Here, see, we are playing with this array, no, np dot array, because this is a small array with us, a 3 cross 3 array. You see A here, it's a 3 cross 3 array. When you have a 3 cross 3 array here, it is easy to do using NP, Numpy. But when you have a huge data set, you want to solve that, you want to load it, you have to use pandas data frame. Okay, so that's why I said we are solving system of linear equations for small data sets. So I have loaded the array, I have loaded the B array, I have just used one command, np dot linear algebra dot solve a and b. It is giving the solution. What is this 1 4 minus 2? This is the x1 x2 x3 values, or you can say this is w1 w2 w3 values, weight 1 weight 2 weight 3 values. Okay, see, these are the values of x1 x2 x3, right? You can even calculate determinant in that linear algebra. This lin alg has lot of functions in it, lot of functions which we regularly use. So np dot linear algebra dot determinant of a, simply give this, it shows you determinant of the value minus 60. Okay, so if you normally, if you can calculate for determinant for this, you can observe the answer will be minus 60. So instead of spending a lot of time finding out the determinant by doing some calculations, Python programming is giving you very easily, right? So yeah, this is one case. What happens if the system has no solution, no unique solution? It means sometimes the given we have seen, right? We can, for given system of linear equations, either we can have a unique solution, infinite number of solutions, and no solutions. So if there is no unique solution, suppose you give like this, you have this system of linear equations, you want to solve this. So I convert it into array, I convert it to B array, A array, and I am giving the command np dot linear algebra dot solve. I am giving two arrays. I'm giving two arrays, right? So when you click on this, when you run it, it will throw you error, linear algebra error. Why is it giving so? It is not singular. It is, see, singular. This matrix is singular matrix. Again, I'll go back, singular, non-singular. If you remember, we have seen English sentences. The dog is black, cat is orange, bird is red. Three statements are different, complete, they are non-singular. Singular means either there are repeating statements or there are no contradictory statements, redundant statements or contradictory statements. In such case, such kind of systems are singular. So you cannot find out solution for singular matrices, right? Why? How can you say singular matrix? If its determinant is 0, you see the determinant is 0. When the determinant of the matrix is 0, it means it is singular. And for singular, we cannot find out, we cannot solve the solution. We cannot find out the solution for that given set of system of linear equations. Okay, so even if we give, it will say that the given matrix is a singular matrix, we cannot solve it, right? So this is a little about how we solve given system of linear equations. So yesterday's full session is just converted into a small programming, two commands you are writing. You are just loading the library np numpy as np, you are reading the two matrices a and b, and you are just using the command np dot linear algebra dot solve and np dot linear algebra dot determinant if you want to find out. Same way, today whatever we are going to learn, eigenvalue, eigenvector, everything can be solved quickly. Okay, I hope you got little idea. Is this clear?